Okay, hello Advanced Algebra. A couple reminders. Remember, we do have a quiz tomorrow. Today, after these notes, you'll be working on the quiz review. Today, we just have to wrap up just one note sheet. So you should receive the packet that should have been handed out to you, and we'll go ahead and fill out these notes over solving by factoring. So today is going to be a lot of using the factoring that we've learned the past couple days to solve quadratics. Just remember, there's three ways to solve quadratic equations. Graphing, which we worked on earlier in the week. Remember, to solve by graphing, you just have to find the zeros or the x-intercepts. We also called those the solutions. Okay, so that's one way to solve a quadratic equation. Graph it, find where it crosses the x-axis. And then today we're going to use the zero product property and factoring to solve a quadratic equation. So that's what we'll work on today. And in the notes here below, just keep in mind we can have one solution, two solutions. We can also have no solutions to a quadratic equation. And remember, when we find these solutions, these are the x-intercepts of the quadratic function when they're graphed. Okay, so let's talk a little bit about the zero product property. Basically, the zero product property says if you have two numbers that are multiplied together and it equals 0, that means a equals 0, b equals 0, or both a and b is equal to 0. Okay? So what that allows us to do is if we have two factors, like x plus 3 times x minus 5, that is equal to 0, then we know one or the other or both of them are equal to 0. So we can take each factor, set them equal to 0, and then we can solve for x. Okay? So that's how we're going to use the zero product property today to solve. So in this example below, let's practice using the zero product property. First of all, we're going to want to find the zeros. So let's set this equal to 0. Now, if we know this is equal to 0, then we can use the zero product property. We only care about the factors that have an x value. So this negative 3, we're not going to set that equal to 0. This factor has an x value. So using the zero product property, we know that x plus 4 equals 0, or x minus 2 equals 0, or both of them. So we can set them equal to 0, and then we can solve. So this would be x equals negative 4, and this would be x equals 2. So my solutions for x there would be negative 4 and 2. Now let's look at one that's not factored for us. So if we wanted to solve the following equation, to solve, we want to set the function equal to 0. Okay, but we want to find the solutions, the zeros, the x-intercepts. So we set it equal to 0, and then we need to factor. Okay. Now, you should recognize from earlier in the week that this is an easy trinomial. So I need to figure out what multiplies to negative 6, or my factors of negative 6. But they have to add to negative 1, or their sum has to be negative 1. So if we brainstorm factors of 6, we have 1 and 6, 3 and 2. Since it has to multiply to negative 6, one of those numbers has to be negative. Well, in order to add to a negative 1, it would have to be negative 3 and positive 2, which would add to negative 1. Okay, so my factored form here would be x minus 3 times x plus 2 is equal to 0. So once you have it factored, now you can use the zero product property. So we know x minus 3 equals 0, x plus 2 equals 0. And we can solve those equations. So we find one solution is going to be x equals 3. The other is going to be x equals negative 2. Okay. So remember, these are our zeros, our x-intercepts are our solutions. So if we wanted to graph this quadratic equation, we would know that they would cross the x-axis at 3 and negative 2. Okay, before we get too far solving quadratic functions by using the zero product property, I want to review some factoring because you're really going to need to know how to factor. So I want you guys to spend some time trying these 4 problems right here, okay? So I want you to try these on your own. You may have to look back at your notes to remember how to do GCF and difference of 2 squares and easy tries and tricky tries, okay? But I want you to try these 4 on your own. Pause the video. When you're done, you can hit play to check your answers. Okay, so go ahead and check your factoring problems there. Awesome. Okay. Once you've had a chance to check, let's move on to the next section where we're going to practice some more solving. All right. And again, there's really 2 steps to this. Okay. Well, 3 really. You need to make sure that it's set equal to 0. Then you need to factor. And then you need to solve using the zero product property. Okay, so those are the steps we're going to use as we go through these problems. Okay, I'm going to jump around a little bit on this section and have you guys do some on your own. But let's start with number 1. Okay, so first I'm going to check that it's set equal to 0, which it is. And then I'm going to factor. So looking at this, I see that it's 2 terms. I'm always going to start by trying to take out a GCF. And it looks like I can take out an 8 and an x from both of these terms. It's the greatest factor that I can remove. So we'll take out an 8x. That leaves me with the 2x and plus 1 after I divide. Okay. So now that it's factored, we can use the zero product property to solve. And remember, we care about all the factors that have an x. So this 8x is a factor, okay? So we need to say 8x could equal 0. 2x plus 1 could also equal 0. So that's where we use our zero product property, and now we solve. Divide by 8 here, and I would get x equals 0. And divide by 2, and I would get x equals -1/2. Okay, I'm going to jump down to number 4. Again, we're going to move around a little bit, and at the end I'll have you do the other ones on your own. Okay, so first we have to check, is this set equal to 0? X squared equals 25. Nope, it's not. So to get it set equal to 0, we need to subtract 25. We got to move everything to the left side. So I would get x squared minus 25 equals 0. Okay, now we can factor this. And hopefully you're recognizing that this is a difference of 2 squares. X squared is a perfect square, and 25 is a perfect square. And it's a difference because it's being subtracted. So we can factor this into x plus 5 times x minus 5. And now we can use the zero product property. So x plus 5 is going to equal 0. X minus 5 could equal 0. And then we solve. And positive 5. And again, remember, these are our solutions. There are x-intercepts if we were to graph them. We also refer to them as zeros. Okay, the next one we'll do together is number 5. So first we're going to check, is it set equal to 0? It is. So now we're going to factor. Hopefully you recognize this as an easy trinomial because it's just x squared in front. So let's brainstorm our factors of positive 12. And we want to find the 2 factors that add to positive 8. Well, factors of 12, we have 1 and 12. 2 and 6, 3 and 4. Both of these factors need to be positive, or both need to be negative to add to, or to multiply to a positive 12. But in order to add to a positive 8, we're looking for two positive factors. So if you look at our chart here, positive 2 and positive 6, those are going to be the two factors that add to 8. Okay, so this would factor into x plus 2 times x plus 6. Now that we have it factored, we can use the zero product property to solve. I would get x equals -2 and x equals -6 as my solutions for this quadratic. Okay, the last one we're going to do together is number 8. So first we need to make sure that it's set equal to 0. It's not, so I need to move the 7 to the left side of the equation by subtracting. Now that I have it set equal to 0, I'm going to try to factor. Now, to factor this is going to be a tricky try because there's a 3 in front of our x squared. Okay, so remember we're using guess and check. And in the first positions in parentheses, we have factors of 3x squared. So that's going to be 3x and 1x. And then in the second positions in parentheses, we have to use factors of 7, -7. And that's going to be 1 and 7, all right? We know if they multiply to a negative, though, that we have to have a positive and a negative. But we'll handle those signs later. I'm just going to guess 1 and 7, and we'll check our inner and outer products and see if it works. So this would be 1x and 21x. And keeping in mind that one of them would be positive, one of them would be negative, is there any way to get them to add to a positive 4? It doesn't look like it on that one, right? So back to the drawing board. Let's switch the positions of the 1 and the 7. And then check your inner outer products. That give me 7x and 3x. Okay, keeping in mind that one has to be positive and one has to be negative, is there any way to get them to add to a positive 4? If 7's positive and 3 is negative, that would add to a positive 4, which would match my middle term. Okay, so that tells me that 7 has to be positive and the 1 has to be negative. And that would be the correct factored form. All right, we're going to make some room here. Get rid of my inner and outer products now that we have it factored. All right, now you're going to use the zero product property. So 3x plus 7 would equal 0, or 1x minus 1 would equal 0. And then you just have to solve those two equations. So one of my solutions would be -7/3. Just leave it as a fraction. And the other solution would be x is equal to 1. Okay, hopefully you're feeling okay on solving quadratics by factoring and using the zero product property. What I want you to do is try the problems that we did not do. So number 2, number 3, number 6, and number 7. Make sure they're set equal to 0, factor, and then solve using the zero product property. Pause the video and try those 4 problems. When you're done, hit play so that you can check. Okay, there is the solutions to the rest of those problems. Once you've had a chance to check those and make any corrections as needed, remember your homework tonight is the Chapter 3 review. For the quiz tomorrow, Let me know if you have any questions, and I hope you guys have a great rest of the day.